Good day, grade 11s. Today we are going to look at finding the point of intersection or the coordinate of intersection of two lines. Okay, so let's look at this diagram that we have here. We've got our x-axis and the y-axis, and we've got these two lines, line AB and line FG, that are meeting at point P. So our exercise would be to find the coordinate P, the point of intersection, which is a question that you are likely to get now or later when we do functions. So it is important that you master the concept now on how to find the coordinate of intersection. Okay, so it is also given that the equation of the line FG, as you can see, there are no coordinates provided for FG for us to be able to find the equation. So the question has provided FG for us, and the equation is 4y plus 5x equals to 3. So so how do you find the point of intersection? The first thing that you must remember is that at point P, okay, first of all, please do not assume that these two lines are perpendicular and then you think you can then maybe just use that. If there's no 90 degrees here that shows that they meet at 90 degrees, we cannot assume that they are perpendicular. Okay, I just wanted to point that out. We do not use assumptions. We have to use information that is provided. All right, coming back to the point of intersection, at point P here, the equation AB and the equation FG have the same x value. The x value is going to be this one, and they have the same y value, which is going to be this one. So it means we say the equations at this point P are equal. So that is what we use. At point P, the equations are equal. So that means we need to find the equations of both FG and the equation of what? Of AB. So FG has been provided for us. So that means we need the equation for what? For AB. Now, if you check AB, they've provided us with two coordinates. So if we have two coordinates, then we are in luck. Remember, for you to find an equation, you need to have what? The gradient, and then you need to have one coordinate. So now they've provided us with two coordinates because we first need to calculate the gradient. So for AB, we calculate the gradient. So that's what I did. Calculate the gradient. It's 6 minus -2. That is why here it is now plus. And then we have 4 minus -6. That is why it is now plus there. And then when you add that, you get 8 over 10, which then gives you 4 over 5. And then after you found the coordinate, then the gradient, then you can use one of the coordinates then to find the equation. Remember, the equation that we use is y minus y1, which is equals to m x minus x1. That is what we use. So then you have to just choose one coordinate. So meaning I chose the one that is that has positive values. You can choose any of these. That's why I wrote here one of the coordinates. So it's up to you which one you choose. I've chosen the positive one. I've written it down there, and then I used the gradient, substitute, and then tidy it up, and then it gave me y equals to 4 over 5x plus 14 over 5. So now I've got the two equations. Okay, so this one I've also had to tidy it up a bit so that it looks in or sits in this format, y is equals to mx plus c. So I tidied it up and then it looks like that. Right, so now I've got the two equations. So remember, we said at point P the two equations are equal. So that means we are going to solve these two simultaneously. So now you guys have solved simultaneous equations. So this will be your equation 1, and then this will be your equation 2, and then you just solve simultaneously. So you can use any of the methods solve for simultaneous. You can use elimination, or you can use a substitution. Okay, so I have used a substitution, which then just becomes equating, but in J it's still substitution. Why do I say that? I need to say y. It says y, so I can take this and put it in this in the place of this y. So it's substitution. So you solve them simultaneously. So this is equal to that, and then say letters on one side, numbers on the other side, and then it gives us x, which is equals to -1. Then you substitute the x value that you have found in either the equation here AB or the equation of FG, which is what I have done here. So I substitute I used AB, substituted in AB, and then it gave 4/5 times -1 plus 14/5, which then gave me y, which is equals to 2. Now remember, we are looking for a coordinate, so it is not enough to just leave the answers like here. You have to form the coordinate. So if you leave the answer here, it will be incomplete. So P is then going to be -1, 2. That's what I wrote here. Make sure that you write the coordinate. Now, after you found this, other questions that can follow would be, one would say, show that FG is perpendicular to AP. Remember, it's an assumption that you would have gotten to because it looks like they are perpendicular, but we are not allowed to use assumptions. So now the question says show that they are perpendicular. So now remember, the relationship between parallel and perpendicular lines can only be established with what? With the gradients. So you have to use their gradients. So a gradient here FG is -5/4. Gradient here AB is 4/5. Now, if they are perpendicular, when you multiply them, they'll give you -1. So let's see, -5 times 5/4. When you multiply this, it gives you -1. So it means FG is perpendicular to AB. Or you could have said, you could have taken this one and did -1 over this one. If you do that, it gives you 4/5, which is the gradient of AB. So, and then again, you conclude like that, and then you say the gradients are, so they are perpendicular because the gradients are negative reciprocals of each other. Okay, then the other question that can be asked is that show that FG bisects AP. Bisect means it cuts it in half. So if FG bisects AP, it means it would say this point P will be the midpoint, AP. So that is what you must show. That's what I've written here. If FG bisects AP, then the midpoint of AP will be at coordinate P. So you have to find the midpoint. So finding the midpoint would be 4. So let's do that. 4 minus or plus -6 over 2, and then we have 6 plus -2 over 2. So we are looking for the midpoint, and then it gives us, this gives us -2 over 2, and then this gives us 4 over 2, which then simplifies to -1, 2, which is the same as what? The coordinate P. So that is how you show that the line FG, this line FG, actually bisects this one, because the midpoint of AP is actually the point P where FG goes through. All right, so that's all on today's lesson. So please do exercise 7. It's just on the intersecting lines, so that you can practice to write the equations more and then finding the point of intersection. So do exercise 7. It's not a lot. It's like four sums on exercise 7. Okay, thank you.